Hello friends, welcome to Learner's Planet. Friends, this is our third session for real numbers. In the previous session, we discussed Euclid's lemma, we discussed fundamental theorem of arithmetic, and we did some problems based on HCF and LCM also. We found out the HCF by Euclid's method and from prime factorization method as well. So in this session, we'll be taking problems based on real numbers, right? And I'll be taking the problems from NCERT textbook also. So just let's begin the session. Now friends, let's take the first problem from NCERT textbook. Show that every positive even integer is of the form 2q and that every positive integer is of the odd integer is the form of 2q plus 1 where q is any integer, right? Now we have learned the Euclid's formula that dividend is equal to divisor into quotient plus remainder, right? So we just use this concept to prove this theorem, right? Now see, dividend, that means we can take any number. Suppose we take a number a, right? So if a number is divided by 2, the remainder will be between 0 to 1, right? Either it will be 0 or it will be 1, right? Or we can say remainder will be greater than equal to 0 or less than 2, right? So remainder can be either 0 or 1 if we divide any number by 2, right? Because the remainder should be less than 2, right? So if I divide a by 2, so divisor will be 2. Quotient, I suppose q is any integer, so is q, and remainder will be either 0 or 1. That means a is equal to 2q plus 0 or a is equal to 2q plus 1. That means what is happening over here? A is either an even integer because a is equal to 2q. That means a is any multiple of 2, or a is 2q plus 1, right? That means either a is an even integer or it is an odd integer, right? So every positive integer is a form of 2q and that every positive odd integer is a form of 2q plus 1, right? So that we have proved over here, right? So I hope you are clear. Now show that every positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer, right? Now we assume any number that is a, right? When a is divided by 4, we assume the quotient is q. So a is 4q plus remainder will be between 0, 1, 2, 3, because if we divide any number by 4, the remainder will be either 0 or 1 or 2 or 3, right? So a is either 4q plus 0, a is either 4q plus 1, a is either or 4q plus 2, or a is 4q plus 3, right? Now the possibility of a is, these four possibilities are there. Now since a is any positive odd integer, right? But in this case, see, it is 4q, right? And q is an integer, so a will not be odd number over here, so we discard this, right? A cannot be 4q. Similarly, in this case, a is 4q plus 2, that is further a is an even number, so even this is not the possibility. That means we are left with 4q plus 1 and 4q plus 3, right? So a is an odd number, so odd number can be represented in the form of 4q plus 1 or 4q plus 3, right? So this is how we can prove this axiom. I hope you are clear. So these are the steps that you have to write in your exams, so be very clear about that. See, the problems are not difficult. You just the important thing over here, just how to write the steps, right? So these are the steps. I just mentioned one more thing over here. Remainder should be greater than equal to 0 and less than 4, right? If you divide any number by 4, the remainder will be between 0 to 4. That means it can be 0, 1, 2 or 3. 0, 1, 2 or 3, right? Now in this question we have to prove that the number 2, that is root 2, is irrational, right? Friends, we go by the contradiction. We assume that root 2 is a rational number, right? I assume root 2 is rational number. Now every rational number can be presented in p by q form, where p and q, both of them are integers and q is not equal to 0. That means I can write root 2 is maybe p by q, right? Now one more step. Since we write down root 2 as p by q, maybe there are any other factors, maybe say p and q is 3 and 6, right? So maybe there are any other common factors except 1. So what I do is I just take out the common factor of p and q, so reduce it to co-prime numbers, right? So root 2 is co-prime numbers, maybe a by b, right? Where a and b are co-prime to each other. A and B are co-prime to each other. Because we are discussing every possibility. See, root 2 is a rational number, that is correct, that is p by q. But if there is any common factor between the two, that means this is not the simplified form, right? So we eliminated the common factors of p and q. So to get the fraction as a by b, where a and b are co-prime to each other, that means none of the factors are common between a and b, right? That means root 2 is equal to a and b, right? Now a is equal to b root 2, or we can say a square is equal to 2b square, right? That means what? A square is equal to 2b square. That means a square is divisible by 2. Yeah. Now according to the Euclid's prime number theorem, if a square is divisible by 2, a is also divisible by 2. Now if a is divisible by 2, I assume to be a as a new number, maybe a is 2c, right? Because a is divisible by 2, that means a is maybe 2 times of any other common any other integer, right? So a is 2c, since a is divisible by 2, right? Now I got the value a as 2c, so I put the value of a in this equation. Maybe this is equation 1. Just wait a moment. So I just get the value of a over here. So it's 4c square is equal to 2b square, right? That means this. That means b square is equal to 2c square. That means what? B square is also multiple of 2. That means b square is divisible by 2. Means b is also divisible by 2, right? According to Euclid's lemma. Now here we see a is divisible by 2, and here we see b is also divisible by 2, right? And over here we assume that a and b are co-prime to each other, right? So if a is divisible by 2, b is also divisible by 2, that means a and b are not co-prime to each other, right? So what we assumed, root 2 as a rational number, that was incorrect, right? So in fact root 2 is an irrational number, and these are the steps to be followed, right? Okay, first of all, we assume root 2 be a rational number, so we got root 2 as p by q, right? After that, we eliminated the common factor between p and q, so we got a new fraction, that is a by b. So a and b are co-prime to each other. Now a is equal to b root 2, we just did a cross multiplication, then squaring. So a square is equal to 2b square. So according to Euclid's lemma, if a square is divisible by 2, a will also be divisible by 2, right? Now if a is divisible by 2, we can assume a third integer may be c, right? So a will be equal to 2c because a is like multiple of 2, right? Now we put the value of a as 2c over here in this equation. So we got 4c square is equal to 2b square. That means b square is equal to 2c square. That means what? B is also divisible by 2. B square is divisible by 2. That means B is also divisible by 2. Now if A is divisible by 2 and B is divisible by 2, that means A and B have a common factor as 2. That means A and B are not co-prime to each other. That means our assumption that root 2 is a rational number was incorrect, right? So with these steps we proved that root 2 is an irrational number, right? I hope you are clear, and this is really very important problem from NCERT textbook. So just revise it 2-3 times if you are not clear. Now on the same line, let's prove that root 3 is an irrational number. Friends, all the steps will be same, right? Now just go by contradiction. We assume that root 3 is not an irrational number. That means I just write the steps. Assumption root 3 is not an irrational number. That means root 3 is a rational number. Now every rational number can be written as in p by q form. So I just write root 3 as p by q form, where p and q both of them are integers and q is not equal to 0, right? So this is the first step. After that, suppose p and q have a common factor other than 1, right? So we eliminate that common factor and assume root 3 as a by b, right? Now we removed all the common factors and got root 3 is equal to a by b. That means a and b are now co-prime to each other. Because we eliminated the common factors between p and q, right? Suppose p and q may be 4 by 8. So it's 2 was a common factor that we eliminated. Now these two numbers are co-prime to each other. It's just for the understanding, right? In examination you don't have to write this, right? So root 3 is p by q. We eliminated the common factor and got root 3 as a by b. That means if we square and cross multiply, we will be getting a square is equal to 3b square, right? A square is equal to 3b square after we squaring both the sides. Now that means what? A square is multiple of 3, right? A square is divisible by 3. So according to Euclid's lemma, A will also be divisible, or A will also be multiple of 3, or A will also be divisible by 3, right? Now if A is divisible by 3, we can write or we can present A as multiple of 3 with any third integer, suppose c, right? That means A is a multiple of 3, right? And c is any other integer, any third integer. So A can be written as 3c, right? Now just square it. So A square is what? 9c square, right? Now I assume this equation to be 1 and this equation to be 2. Now just compare these two equations, right? A square is 3b square and A square is 9c square. That means what? A square, the that is the value of a square from here and from here can be equated. That means 3b square is equal to 9c square. That means b square is equal to 3c square, right? Now it means b square is divisible by 3 because b square is what? 3c square, right? So b square is divisible by 3. That means b is also divisible by 3 according to Euclid's lemma. That means, see here, b is divisible by 3, and here we have proved that a is divisible by 3, right? And here what we have done here, a and b are co-prime to each other. Now if a is divisible by 3 or a is multiple of 3 and b is also multiple of 3, that means a and b cannot be co-prime to each other because they have a common factor 3 as a common factor S3, right? So a by b, a and b are not co-prime to each other. That means whatever we assume that root 3 is a rational number is incorrect, right? So root 3 is not a rational number, but it is an irrational number that we have proved. Again, this is very important problem from NCERT textbook, so do revise it once again, right? Now friends, next for from NCERT textbook is we have to prove that 5 minus root 3 is an irrational number, right? So the same way we'll go. First of all, we'll assume that 5 minus 3 is a rational number. Assume 5 minus root 3 is a rational number. Now every rational number can be written as in p by q form, where p and q, both of them are integers and q is not equal to 0, right? Now what? Root 3 is equal to 5 minus p by q, right? Now this is here very important concept is there, just listen to me carefully. See, 5 is a rational number and p by q is also a rational number. So if we get the difference between a rational number and a rational number, we will be getting a rational number, right? So this is what a rational number. That means right hand side is a rational number. On the left hand side we are getting root 3, and root 3 is what? Irrational number, right? That we have just proved. Now left hand side is an irrational number and right hand side is a rational number, so it is not possible, right? That means root 3 is not equal to 5 minus p by q. That means the assumption taken by us that 5 minus root 3 is a rational number was incorrect, right? That means 5 minus root 3 is an irrational number, right? This is also from NCERT textbook, so just learn it carefully. Now friends, let's take this problem. Prove that the square of any positive integer is of the form 3m or 3m plus 1, but not of the form 3m plus 2, right? First of all, suppose I assume an integer to be a, right? Now if a is divided by 3, the remainder will be either 0 or 1 or 2, right? Remainder will be 0, 1 or 2, right? So a can be written as 3, maybe p format. A is 3p plus 1 format, or a will be 3p plus 2 format, right? That means if a is divided by 3, the remainder is 0. If a is divided by 3, the remainder is 1, and if a is divided by 3, the remainder is 2, right? So these are the three possibilities, right? Now we square a. So what a square will be? It's 9p square, or a square is equal to the whole square of this, that is 9p square plus 6p plus 1, and in this case a square is equal to 9p square plus 3 2s are 6, 2s are 12p plus 4, right? Now we have to see these from the multiple of 3, right? So 9q square can be written as maybe 3 times 3p square, right? I just write it over here. The first case, I just take it, the first case is the second case and is the third case, right? So the first case is 9p square. So that can be written as 3 into 3p square, right? So I assume 3p square to be any other integer, say m, right? So it's 3m, right? So, and 9p square is what? A square. So a square can be written as 3m, right? Now let's take the second one. Here a square is equal to 9p square plus 6p plus 1. So we can write, we can take 3 as common. So it will be like 3p square plus 2p and plus 1, right? We assume this to be further an integer that is maybe n. So it's 3n plus 1 format, right? So a square is either multiple of 3 or a square is multiple of 3 plus 1. That means if a square is divided by 3, the remainder will be 1. And the third case is this, right? So from the third case, a square is equal to, it's 9p square plus 12p plus 4. So I take 3 as common. So what I'll be getting, it's 3p square plus 4p, and this 4 that can be taken as 3 plus 1, right? So finally it is 3p square plus 4p plus 1 plus 1. Now this is also an integer and this is multiple of 3. So if a square is divided by 3, the remainder will be 1, right? Because this portion is multiple of 3, right? So here we got the remainder. I assume this to be another integer, maybe say x. So it is 3x plus 1, right? So a square is 3m format, right? Or it is plus 1 format and plus 1 format, right? So according to the question, that any square of any positive integer is of the form 3m or 3m plus 1, but not of the form 3m plus 2, right? So in all the three cases, we are getting either 3m, 3m plus 1 and 3m plus 1 format. We are not getting 3m plus 2 format anywhere, right? So this is how we can prove this, okay? I hope you are clear. Friends, we will be taking more problems in our next session. Do revise this session and the previous 2 sessions of real numbers so you'll feel comfortable in the next session. Bye-bye.